Okay, so we're going to talk about absolute values with inequalities, but this time we're going to be talking about greater than signs with this one. So, same thing that I asked you guys to do before. If you guys would pause the video and tell me what values for x can we plug into this section right here, what can we plug in that will still make that statement be true? So go ahead and pause the video and list those out for me. Okay, hopefully you guys have paused that video. So what values for x be greater than 3? I'm sure that you guys saw 4, 5, 6. All those numbers could work. Some of you guys that are, those kind of kids probably wrote like 3.01, and that's also true. So essentially, if we have 3 here, we wouldn't be including 3, but all of those numbers that are bigger than 3 we would have included. Okay? However, there are some other numbers that would also make this statement true. Okay? What about if we looked at negative 4? No way. Negatives aren't bigger than 3. Except if I'm dealing with an absolute value, because the absolute value of negative 4 is 4. And 4 is greater than 3. So that means we've got some other numbers we could have included as well. We could have included negative 4, negative 5, negative 7, negative 100, and of course, negative 3.01 as well. Okay? So we could also be looking at negative 3, and all the numbers that are smaller than negative 3 would also work because the absolute value is going to be getting rid of that negative 4's. So when I am looking at the absolute value of x greater than 3, the statement that I end up coming up with after that is that x is greater than 3 or x is less than a negative 3. So we end up with an unbounded statement for our greater than. Okay? Which kind of makes sense if you think about it. Your less than statement gave you a bounded interval, so the opposite, the greater than statement, would give us an unbounded interval. Okay, so for my rule, I can say that the absolute value of x is greater than a, and that implies the statement that x is less than a negative a, or x is greater than a positive a. So let's do one example here. Again, the first thing that we have to do when we're doing this with this example is we have to make sure that we get our absolute value isolated by itself first, which this one is. After you get it isolated, you are then going to look at the inequality sign. And this says that it is a greater than. So since that is a greater than, we are going to remember that the absolute value of x greater than a implies the statement x is less than a negative a, or x is greater than a positive a. So when I go to fill this information out then, my x, that's the part on the inside. That would be the 2 minus 3x, right? Part on the inside, that's going to go in both of those spots there. So I'm going to end up with a 2 minus 3x is less than, and a 2 minus 3x is greater than. Okay? Now my a value in this case, my a value here is a 1. So I'm going to have a 1 here, I'm going to have a 1 here. Part of this problem where people get confused is, where does the negative go? Well, less than is for smaller numbers, so the negative is going to go with the less than sign. So I would need to have a negative 1 with my less than sign, and then I have a positive 1 with my greater than sign. And of course, don't forget the or. Okay? When we work solving through these or statements, you just kind of solve them each individually. So that is a positive 2, so I need to subtract 2 to get rid of that there. That gives me negative 3x less than or equals, or sorry, no, just a less than sign, my bad. And of course, if I subtract 2 on one side, I have to do it on the other side. So I get negative 3x is less than negative 3. Divide both sides by negative 3. And I end up getting that x and 1. And since I divided by a negative, I have to flip the sign. I get that x is greater than 1. Okay, now I'll go through and solve the other one. Again, I need to subtract 2 on both sides. Gives me a negative 3x is greater than a negative 1. Divide both sides by negative 3. And I end up with x is, again, we have to flip the sign, less than a positive 1/3. Okay, for your final answer, this is an or statement. They do go together. So you would need to say that x is greater than 1 or x is less than 1/3. Okay. A couple other practice questions here. This one on the right we still don't have filled out. Absolute value of 2x minus 5 is greater than or equal to 9. Okay, first step, remember, is to check. Is this by itself? Do we need to move anything over? Nope, it's by itself, so we're good there. I'm going to end up then with greater than sign, so that tells me I have an or statement. And I'm going to end up with 2x minus 5 is less than or equal to a negative 9. Less than goes with the negative, that's a smaller number. Okay, 2x minus 5 is greater than or equal to a positive 9. I just need to solve these each individually. Add 5, add 5. I get the 2x is less than or equal to negative 4. Divide both sides by 2. Whoops. Divide both sides by 2. I get that x is less than or equal to a negative 2. Don't need to flip the sign there. Divide it by a positive number. Okay. Add 5, add 5. 2x greater than or equal to 14. Divide both sides by 2. Divide both sides by 2. I get that x is greater than or equal to 7. And again, it's very important. That is an or statement. Don't forget to write the or there for your final answer. Okay. Last one you have here, kind of a trickster. Okay. There's no work that you need to show on this one. Your answer for this is all real numbers. However, we're going to write our answer in interval notation, so what you want to say is from negative infinity to infinity. Okay? So how do I know that that case is all real numbers? Well, think back to that first slide. We talked about the absolute value of A is greater than or equal to 0. Okay? And that is because all of your answers for an absolute value are, get in, all of the answers to an absolute value are always positive numbers. They all have to be greater than or equal to 0. So this case right here, doesn't matter what's in here. Any number that comes out is going to be greater than or equal to 0. It's always true. Okay? Same can be said, some other examples I could look at. Say I did absolute value of x plus 1 is greater than negative 3. This answer would also be all real numbers because no matter what this is here, it's going to be a positive number, right? And positive numbers are always greater than a negative 3. Okay? On the flip side of that, if we're looking at less thans like this one here, say I had the absolute value of x plus 1 is less than negative 5. Absolute value of x plus 1 is less than negative 5. So this part right here, your absolute value, that's going to end up being a positive number, right? A positive number is less than negative 5. Is that ever going to be true? Is a positive number ever less than a negative number? No, it's always false. So our answer for this one would be no solution. Okay? How do you write no solution in interval notation? You can't. You're just going to write the word no solution. Okay? So that's going to be your video then for your absolute values. Thank you for your time.